In 1895, the leading physicists of the day said flying machines are impossible. But by 1905, within a decade, the Wright brothers were actually flying. Like the invention of the airplane, this is the true story of the impossible. In 1989, a scientist named Randall Mills made a giant leap in science. For physics, he did the impossible. He solved the math of the electron and the photon. You are seeing light for the very first time in your life. But even at MIT today, 30 years later, they say it is impossible to know what an electron even is.
You're not allowed to ask, where is the electron right now? You are allowed to ask, if I look for the electron in this little particular part of space, what is the likelihood I will find it there? I mean, that bugs anyone, anytime.
While physics had a better solution, it was ignored. How could one man in a private lab change everything? Mills, for his part, tried to tell them, but few scientists listened. His attention moved to another leapfrog idea. The math predicted that hydrogen had an undiscovered, smaller form. He called it the hydrino. When hydrogen was near the right catalyst, it would downconvert to a smaller form. This is the most powerful reaction we know. Meanwhile, science has ignored Mills' electron solution and moved into science fiction.
As far as quantum mechanics goes, we're struggling with it. But when a theory says that an electron can be here, or here, or here, some percent of the time, you ask yourself, does that mean the electron is at all of those places? And if it is at all of those places, when I measure it, why do I only find it at one or another location? We still struggle with this, but some of the ideas that have been put forward are fairly radical. One of those ideas suggests that if an electron can be here, and here, and here, then it is at all those locations, just in different universes. So when you measure the position of the electron in one universe, you find it here. In another universe, a copy of you finds it here. And in yet another universe, another copy of you finds it there. Parallel worlds emerging from the mathematics of quantum physics.
But if hydrino energy is real, quantum mechanics can't be real. There are no multiple universes or copies of you, just one simple electron. Hundreds of scientists have worked on hydrino energy, and there are 100+ articles on the subject. 30 from just 2000 to 2003 alone. But still, physicists ignore this. You can't make this one up. One said in 2016, if I had strong evidence, I would submit it to journals in the field. This is just like the Wright brothers. The impossible is becoming possible. In 2009, Nobel Prize physicists said, hydrino energy is impossible. Nonsense. But in November 2015, at his brilliant light power lab, Randall Mills achieved explosive and sustained hydrino energy. The impossible theory, the impossible energy, was now explosively real. In 2017, BLP partnered with Berkshire Hathaway to build a heating product. In August 2018, they have it running and are in refinement. In October 2018, they are iterating on material science work for containment of this chemical reaction, which burns hotter than any fossil fuel. In December 2018, they have the world's first sustained plasma reactor. But would you feel safe this close to a nuclear reactor? The energy is cost competitive with all other renewable energy we have. It will be critically 1/10 cheaper to install than a solar farm and sell electricity for 5 cents a kilowatt hour or less. Some of the engineering firms working on this are Berkshire Hathaway's TMI Climate Solutions on a heater product. Operating partners to deploy this energy include ABM in the United States, Paragon Power in Canada, and Enextra Energia in Mexico. We are End of Petroleum. Scientists and investors focus on a new source of green energy. I'm Naveed, and as a designer, I synthesize technology and business for disruptive outcomes. In the past, I've led scientific innovation across Canon Medical and founded startups. Kendrick is a certified private equity professional and manages our fund through Kirk & Co Asset Management. He has been involved in private acquisitions and financings totaling $300 million. Brett Holverstadt worked at Brilliant Light Power with Randall Mills in his New Jersey lab, published papers, and wrote the book on hydrino energy. Jessie is our analyst and has worked at CPP, Canada's pension fund, and a VC firm. She also works at TD Bank doing due diligence on hedge funds. We're the only team in the world with hands-on understanding of hydrino energy and the underlying physics and can offer consulting to scientists or impact investors.